Welcome back, everybody. In the next portion of today's lesson, I am going to be focusing on some additional examples of sigma sums. Let's look at the next example together. So guys, we have been given a specific series that we need to determine A, the first 3 terms of the series, B, the 100th term of the series, and by the 100th term, please note that we actually mean T100. Then we are going to determine the value of n if the sigma sum is equal to 80. So guys, just a little note, this sigma looks slightly different, but all it means is that the n is the top value and k is equal to 1 is the bottom value. I'm just showing you this as sometimes it can appear differently in different books. So let's get going with A. So we have to determine the first 3 terms of the series. We have been given our Tn. We know that being given the Tn will allow me to substitute in values. But this one might look a bit different, guys, because I actually have a k. So this, in fact, is Tk is equal to 22 minus 2k. It is the same thing as your Tn formula, except now there is a k involved. So if I look at my substitution instruction, I can see that I'm first going to substitute in for k is equal to 1. This will allow me to find the first term involved in the sum. Cool, so to find the first term, I'm going to substitute k is equal to 1. So term 1 will be equal to 22 minus 2 times 1. So term 1 has a value of 20. Then to find term 2, I'm going to substitute in k is equal to 2. So term 2 will be equal to 22 minus 2 times 2. Please note I've substituted in 2 in the position of k, which is going to give me 18. Then to find term 3, I'm going to substitute in k is equal to 3. So term 3 will be equal to 22 minus 2 times 3, which gives me an answer of 16. Great, everybody. I hope that you are with me so far. The first 3 terms of the series are 20, 18, and 60. Let's move on to B. So the next part of the question has asked me to determine the 100th term of the series. So we are finding T100. So I'm sure that everyone will agree that I have got my nth term. So please remember this is actually supposed to say Tk, not Tn, because we know that the Tn has been expressed in terms of k. So Tk is equal to 22 minus 2k. I am going to find the 100th term. So the 100th term means that I need to substitute in 100 for k. So I'm going to have 22 minus 2 times 100. Substituting in k is equal to 100 will allow me to find the value of the 100th term. So term 100 will be equal to 22 minus 200, which ultimately means that term 100 will be equal to negative 178. Great, guys. I hope everyone is with me. Let's move on to C. So we now need to determine the value of n. So this means this question is asking me how many terms are involved in the sum. So we're determining n if the sigma of 22 minus 2k is equal to 80. Okay, so the first 3 terms of the sequence which we've established are 20, then 18, then 16. It's an arithmetic series, everybody, because there is a common difference of -2. I'm sure that everyone will agree with me that moving from 20 to 18, I've subtracted 2. Then moving from 18 to 16, I have subtracted 2. Because I'm trying to find the n that leads to the series having a total value of 80, I'm going to be substituting in 80 for my Sn. I can see that a is equal to 20 because that is my a value, and I have already established that the common difference is -2. Great, guys. So because I have an Sn, an a, and a d, I'm going to substitute that into my arithmetic series formula, as this is going to allow me to solve for n. Let's do that together. So we know that I'm going to be substituting in 80 for Sn, because I know that is the total of the series. N is unknown, so I'm still going to have n over 2. Then I'm going to have 2 times 20, because I'm substituting in a is equal to 20, plus n minus 1, because I'm going to be having n minus 1 because I don't know the value of n, multiplied by -2. Great. So we are trying to solve for n. Just to get rid of this headache fraction, I'm going to multiply both sides of the fraction or the equation by 2. So I'm going to have 160, sorry, my pen did a weird thing there, is equal to n. So all I've done is have multiplied both sides of the equation by 2. Then in my bracket, I'm going to have 40 minus 2n plus 2. In order to get to that step, I've distributed this -2 into that bracket. I'm going to continue simplifying, so I'm going to have 160 is equal to n times 42 minus 2n. I'm going to distribute my n in the next step. So I'm going to have 160 is equal to 42n minus 2n squared. Hopefully everyone can see at this point that it is creating a quadratic equation to solve for n. In order to solve for that, I'm going to move everything over to the left-hand side so I can handle my trinomial. So the next line will be 2n squared minus 42n plus 160 is equal to 0. In order to make my life slightly easier, I'm going to divide everything by 2. So that's going to leave me with n squared minus 21n plus 80. So the factorized form of this trinomial is going to be n minus 16, n minus 5. So n will be equal to 16, or n will be equal to 5. Now guys, I'm sure that everyone's wondering, why are there 2 answers for n? How come there are 2 different numbers of terms that I can add together to get 80? And the reason for this is that the sum of the terms increases when the terms are positive, and the terms decrease when the terms become negative. So that's the reason why I have 2 n values. Let's look at the next example. Great. Before I go on to the next one, I hope that everyone's with me. I hope that you've got your pen in your hands and that you're doing okay. You've got this. Great. Let's go to the next example. So, if the sigma sum of k plus b is equal to 10a, we need to determine b in terms of a. So, we're first going to substitute in k is equal to 1, k is equal to 2, and k is equal to 3 in order to actually determine the first 3 terms of the sequence. The reason why this is going to help me is because I know that this sum is equal to 10a. So I'm going to be able to use this series to create an equation to isolate B. But I know with sigma sums, I first always have to find the first three terms involved in the sum. So term 1 will be equal to 1 plus B. Why? I'm replacing k with 1. The second term will be 2 plus B, because I'm substituting k is equal to 2. The third term will be 3 plus B. The reason why having those first three terms is going to help me is I'm going to be able to establish my A and my D, because this is an arithmetic sequence. So we have my first three terms. At this point, having my first three terms is going to allow me to find my A and my D. Why is that going to help me? Well, I need to isolate B in my given equation, and I've been given Sn. So I have to find every single piece of information that is going to help me isolate that B. So let's look at the board behind us, and we're going to confirm the value of A as well as the value of D. Let's go back to the board. So we can see the term 1 has a value of 1 plus B, and this is my A. Then we can see that there is a common difference of positive 1 between these terms, because the B remains the same, except we've now moved from 1 plus B to 2 plus B to 3 plus B. So there's been a common difference of positive 1 for each of these terms. So we know that A is 1 plus B, and the common difference is positive 1. Just a reminder, for a summation involving a sigma sum, I have to determine how many terms are being added in this series. I do that by saying the top number minus the bottom number plus 1. So in this case, my top number is 5. I'm going to minus my bottom number, which is 1. Then I'm going to add 1. So there are 5 terms involved in this summation. At this point, everybody, I now can substitute into my arithmetic series formula in order to isolate B. Let's do that together. So we are going to substitute into this formula over here. We know that the summation, the Sn, is 10a. So I'm going to have 10a is equal to n over 2, and we know that 5 is my n. So I'm going to have 5 over 2. 2 times a, and I know that a is 1 plus b. Then I'm going to add that to n minus 1, which is 5 minus 1, because I know n is 5. And my common difference we discussed a bit earlier is 1. Please remember, I'm determining b in terms of a. So my whole goal is to get b by itself. So let's continue manipulating this equation. So I'm going to have 10a is equal to 5 over 2, in brackets, 2 plus 2b plus 4. To make my life a bit easier, I'm going to multiply both sides of this equation by 2 in order to get rid of the fraction. So I'm going to have 20a is equal to 5 times 6 plus 2b. I've just condensed and simplified that bracket. Remember, my whole goal is to get b by itself because I want to determine b in terms of a. I'm going to divide both sides of the equation by 5, so that's going to leave me with 4a is equal to 6 plus 2b. Again, guys, remember I'm expressing b in terms of a, so I want this guy by itself. So I'm going to take the 6 over to the left-hand side, so I'm going to have 4a minus 6 is equal to 2b. And then to get b by itself, I'm going to divide everything by 2. So 2a minus 3 is equal to b. Wonderful, everyone. I hope that you can see how I used the given information. So I had the Sn, and that helped me find the value of b in terms of a. So for these kinds of sums, it's important to look at what you do have and how that's going to help you isolate for the variable asked for in the question. I hope that you've enjoyed today's lesson. I've had a great time and I hope to see you guys very soon.